So when we say sets, we actually mean one, the sets themselves that we know, set A intersection B. Two, we mean surds. Three, we mean real numbers. Under real numbers, we have irrational and rational numbers. And then we also mean binary operations, because these operations are defined on sets. We also mean complex numbers. This is what comprises of sets. This forms sets. So as we go around past papers looking for questions, we'll be there looking for questions sitting in these subsections. So we start. The first paper that I have here is 2020. On question 1, A, part 1. There's a question that says simplify the set B minus A union A complement. This is what they'll ask you on sets. The only thing you need to know is that A minus B, by definition, is A intersection B complement. That's how it is defined. So when we get to our question here, we'll say, okay, then we'll first change this using the definition of minus. So say this is B intersection A complement union A complement, and the complement outside is there. Now, De Morgan's law laws, we have two of them. We have the union one. We said if you have A union B complement, it is the same as A complement intersection B complement. The second one.
Sir, can I please see the, excuse me, sir. Can I please see the previous board? The board before that one.
This is the first one. Seconded by this
then the second, okay. All right, thank you.
Okay. So if I have A intersection B and the complement outside, then you get A complement union B complement. So what we are tapping from these is that when you take the complement inside the brackets, it changes. If it finds intersection, to make it union. If it finds union, to make it an intersection. So we'll do the same here. We'll distribute this complement here. Again, keep in mind that if you have A complement, then you bring another complement, you just remain with the initial set A. So we're going to have B intersection A complement intersection A. Because of the complement, the union has been made intersection. And then from there, you take again this complement, we'll have B complement union A intersection A. From this point, if you find a set A appearing inside and outside, when I mean inside, I mean the brackets, and also it's standing outside with different operations, union and intersection, then the answer becomes A. You can demonstrate this if you want by shading. If this is our A, hello?
Just a minute. The complement one, how did it come about?
We are distributing this complement from here.
So which means the A cancelled with the complement outside for the A?
Which means
the complement for A, which is inside the bracket, cancelled with the outside one.
Yes.
All right.
So if you demonstrate here, B complement union A, the B complement is everything outside B. Okay, everything outside B is B complement. Then union A, everything in A. Intersection A. So intersection A, you notice that it is just the whole A that we're talking about here. That's why we say the answer ends up to be A. And actually this one is a property. You can even say by absorption law. Two, given A is equal to -2 to 6, B is equal to -5 to 3. Hello?
I have a question.
Please ask.
Yeah, sir. As in for B complement union A, what if it was B complement intersection A? Would the answer still be A?
If you had B complement,
okay, sir, is it possible that you differentiate the intersection A and B complement union A in how you can show in the Venn diagram?
Is it possible to?
As in how you, is it possible if you can differentiate the B complement intersection A and the B complement union A in the Venn, if you are showing in the Venn diagram?
You do the expansion of this. Oh, did I get you? Oh, you mean how can we put this in the Venn diagram? Just like we did for the other one. I think I missed your point. Better, are you still there?
Yes, I didn't get what you said.
I didn't get your question fully. Are you comparing this to this one in the Venn diagrams or? Okay, I just make a statement about this one. If you have B complement intersection A is no longer A. Okay, the answer here becomes B complement intersection A. Why? Because if this is A and this is B. B complement intersection A is this part. This part intersection A. This part intersection A is this part. Intersection does not introduce a new thing. Intersection sticks to the already existing thing. So what you have shaded, which part of it is in A? So you notice that the other part of A here hasn't been shaded. So you cannot generalize to say it is A. So it can only be simplified to this one.
Sir, can you repeat? I was logged out, so I didn't get what you said.
So here we are saying that if you have intersection, it changes from this conclusion here. Because if you shade, you have the B intersection, the B complement intersection A takes the black lines. Then intersection A, the red lines. A, when you're intersecting, you cannot go to something that hasn't been touched and say I'm intersecting. Intersecting is looking for the common things. So you go to the already shaded things to go and shade what is in A. So you notice that this part of A won't be talked about, so you cannot generalize that it is the whole set A.
Okay. All right. So, just a minute. So you're saying, sir, that B complement union A and B complement union A, it is A. Then B complement intersection A is just the same as B complement intersection A.
Yes. When you attach this. Okay. Then now we are given these sets A, B, C intervals. Find A union B complement union C complement. You can simplify this one step and say A union B intersection C complement. Okay. The easiest to use is a number line. So you say, even if no one has asked you to use a number line, it's the easiest to use. So you get, we are looking for C complement first. Now C runs from -1 to 8. It has these. They are telling us that 8 is part of the set, -1 is part of the set. So you include like that. So this is C. So its C complement will open at A at 8 because 8 is already in C. It will go where there is no C. It will open there and go where there is no C. So this is C complement. C complement. In our brackets there, we want B intersection C complement. So we already have the C complement. This one here, this is C complement. This is C complement. Now we want to put B. B is starting from -5, or let me put B in red. So B is starting from -5. It will go all the way up to 3. It does not include -5. It's open. So you open at -5 and open at 3. And then go up to there. Okay? You can shade B. This is B. You can shade B. The intersection is where you're going to have 2 lines. So where the black lines and the red lines meet, that is the intersection. So this side of C complement here, we don't even have anything that is ready. So we can't be bothered about that section. So what is common is opening here and opening here. So So this piece, which is running from -5 to -1, they are all open. This is B intersection C complement, that section. Now this B intersection C complement, get the union with A. So go to A, union, the answer that we have found in here. So A is from -2 to 6, union -5 to -1. Again, don't go on that date number line there to confuse you. Form another one where you only have 2 intervals. You have from -2 to 6, closed, open. It goes. We also have,
Sir,
hello,
excuse me, sir. The blue line is representing what?
the common piece
Between
C
between what
complement, between C complement and B.
and B?
Yes.
Okay. All right. Thank you.
Okay. Then now, this is -2 to 6. Then you come and pick also -5 to -1. -5 is open, -1 is open. So you have that one. Union means get everything that is there. So you get this whole thing. After that, get this whole thing again. Okay. So it means that our union will start from -2, because you're getting start from -5, because you're getting everything. Start from -5, go all the way up to 6. Because I'm not leaving anything in between, because whether it's like the upper line, which is A, which is what you have gotten here as B intersection C complement, and this line, which is A. The upper line is open at -1, but it doesn't matter because the down line is closed there. So in the down line, there's -1. So it is part of the union. So the union will come out to be from -5 to 6. Number lines are nice. It's rare that you can make a mistake on the number line.
But can you use set sign in place of number lines?
Yes, you can.
Yeah, because it's also coming out.
Yeah, in fact, we've been using sets. That's why today I've decided to use number lines. So we have got 2 versions. Hello?
Can you please repeat how you combined the just the last part where you said A union B intersection C how you have combined it to get -5,6?
So the combination comes from the number line. Since everything is shaded from -5 all the way up to 6, then it becomes our union, because union is addition. So we're not doing reasoning here. Here we have left it. We've gone to the number line and check. Where do we start from? We start from -5. We end where? At 6. Is 6 included? No. Is -5 included? No. So this becomes the answer.
So,
Hello.
so if at -5 it was closed and then -2 it was open, do you still use the square bracket?
Yes, sir. What determines it to be open or closed once you get your answer?
The word is still does not secure because we haven't used the close bracket. If it was closed at -2, the way it is no, or if it was open at -2, we open at -2, open, go to 6, Suppose we close here. And then at -5, we close, go all the way up to -1, we open. Our answer would have been, because you're getting the union, so you'd shade here, everything will be shaded up to there. So the answer then would be -5, 6. When do you close? When the number is included in the set where it is coming from. So for you to do this, it means that on the interval you had this. For you to do this, it means on the interval you had this. That's what determines the closing and the opening. And in the union, if one is there, if this set includes this, the other set does not include it. In the union, it is there. But in the intersection, it won't be there. Okay, we still have a lot.
Sir,
Hello?
before we move from this board, I'm really sorry to take you back. What did you say on the B complement intersection A bracket intersection A?
Intersection, so we said the answer would be B complement intersection A. A bigger set,
Yeah.
intersection, a small set, you get the small set. So B complement intersection A is a subset of A. So when you intersect them, you get the subset. So we're demonstrating that if this is A and this is B, B complement intersection A will be this section of A. That section of A, intersection A, is just that same section of A.
All right, thank you, sir.
Sir, wait, the previous board. Right, thank you.
So I have a question on the last thing you were illustrating.
What's your question?
Why are we including -2 and -1 when it wasn't included in A and B C complement there?
No, in the union, you don't look at the inclusion in both sets. You just look at, does it belong in one of the sets?
So it's wrong if, let's say, I say from -5 closed to -2 open, union -1 open to 6 closed.
It will be wrong because you leave out the middle interval from -2 to 1. Well, there are so many numbers in between them.
So we include them even though they were not included in the previous set.
There's no previous set. They are included in these sets.
No, like from there, from -5 to -1, -1 is not included. So why are we including it in that final
So
answer?
-1 is not included in this interval, but it is included in this interval.
Right.
And you're getting the union, which is addition. Okay, B1, express 1 plus √2 squared in the form A plus B√2. Okay, so you see there's no denominator here. It's just almost in that form. The only thing that is making not to be in that form is the square. So ours is just 2 square. So this guy multiplied by itself is what the square means. So you get 1 plus root 2 plus root 2 plus root 2 squared. But you understand that root and the square takes care of each other. So you remain with root 2 plus 2. Now 1 plus 2 is 3. Root 2 plus root 2. It's like you have 1 root 2 plus 1 root 2. So you add their coefficients. You get 2 root 2. That's all.
So
Hello?
can I see the previous board for the set that was logged out? Thank you.
Then 2, express root 2 over 1 plus root 2 squared in the form a plus b root 2. So you say, oh, this guy is what I was expanding there. So it is root 2 over 3 plus 2 root 2.
Sir, sorry, my screen froze. Can you explain this on your phone?
Which one? 1 or 2?
That one, this one here for express what?
So here you're just expanding. So I'm multiplying 1 times 1, you get 1. 1 times root 2, you get root 2. Root 2 times 1, you get root 2. Root 2 times root 2, you get root 2 squared. But the square will take away the root. So it remains with a 2. 2 plus 1, 3. Then root 2 plus root 2, you get 2 root 2. So you have 2 of them.
Oh, that what of that cube I'm seeing on top there?
It's not cubed, it's 2. Square. 2.
All right, thank you.
Okay. So if you want to now here, you have this situation here. To express it in this form, you rationalize. So you have root 2, 3 minus 2 root 2 over 3 plus root 2 root 2 multiplied by 3 minus 2 root 2. So you say root 2 times 3, you get 3 root 2 minus 2 root 2 times root 2 over 3 times 3, we get 9 minus 3, 2 root 2 plus 3, 2 root 2 minus 2 root 2 multiplied by 2 root 2. So the numerator remains as it is. One thing we'll do is multiply. What is root 2 times root 2? We have demonstrated there that it is 2. So you have 2 by 2. And this guy here, it is negative of this positive, so it gets 0. So we'll have 9 minus 2 times 2, we get 4. Root 2 times root 2, we get 2. So we get 3 root 2 minus 4 over 9 minus 8, which is 3 root 2 minus 4 over 1, which is equal to 3 root 2 minus 4. We've been told to express it in this form. So we can start with 4 and then end with 3 root 2. Like that. So this concept here is just about how to rationalize. How to rationalize. That's the key thing. How do you rationalize? And this is how we rationalize. So we'll be logged out. Please, once you're logged out, you quickly log back. We still have some more questions.